We all take a lot of photos with our iPhone and they are uploaded to Apple's iCloud. I'm sure many of you have seen this error before, saying iCloud storage is full and you are forced to buy Apple's subscription plan. So sometimes we wonder, why could there be so many photos? Well, there are two culprits. First culprit is that we tend to take near identical photos. Sometimes we just hit the shutter button. Sometimes we just hit the shutter button multiple times and end up with multiple images. So we'll get to that problem in a future video. For this video, the other culprit is that Apple is storing a very high quality image format called HEIC. And in many use cases, we don't actually need such a high quality of images. So this is an opportunity where we can optimize. So we're going to use Claude Code to write a program that can reduce the image sizes so that we can save a lot of space on iCloud. And hopefully you're not going to pay Apple the subscription plan moving forward. Let's get to that. So we want to write a CLI program that enters a directory of image files. So this is just like your iCloud. It's a directory of image files. And you transcode them to small sized JPG file of the same resolution. We don't want to lose resolution, but we can sacrifice some quality because actually to many humans, this is not even noticeable. Okay, so this is the requirement. There are more details to this. First, more details. The directory may contain subdirectories. So you should do a tree walk to find all image files. Second, we will focus on HEIC format image files only. Third, the transcoded files should be named the same and stored in the same path. So basically, we want to overwrite the original HEIC files, and then we can remove the HEIC files. So this is all the requirements for this program. And then we want to get to how to test this program automatically. So Claude Code can work autonomously until it achieves this objective. To test, use a conda environment called photo size reducer. This is just a naming convention. Okay, you can use the examples in the test folder. The success criteria is that the image files you generate is significantly smaller than the original files. Okay, so in order for it to run autonomously, we need to prepare some test files. Let's see. Okay, so this is my iCloud photos, and we can pick up some files. You can see this file is 5.3 megabytes. So let's just copy this to here. We create a test folder, and we can try to mimic the directory tree here. Let's just copy here. Okay, and let's create another one. Let's call A. Find some other photo from here. How about this one? Put it to A. Okay. So we have two files for testing. First one is 3 megabytes. Second one is 5.3. Let's get it to work. So firstly, we run it under plan mode. This is to make sure that Claude Code understands my requirement precisely. Let's give it a wait. So firstly, Claude Code would do some research and see what's available, what's not, and then it will create a plan for us. All right, so this is the plan. I don't want to read in all the details, but just quickly scan through it to make sure that it will verify as planned using the existing test coppers. Dry run first, keep original runs, full run. So it's actually pretty good. So it try not to destroy the original files. This is very smart. Let's get to code. So you can unfold these arrows to see what Claude Code is working on. For our exercises, we're not going to read the source code. We just want to see what are the steps that Claude Code is taking. All right, let's see what it's doing. So it's running some transcode test files. ML essentially the same as the size. CSV is more efficient coded than JPEG. So let's lower the quality. So quality 65 gives 25% reduction. Okay, so it actually defines what is significantly smaller. So this is a match that we intentionally make it ambiguous. So Claude Code actually defines what means significant. Issues to investigate. So in most of the cases, we don't need to worry about all this internal conversation and we just care about the final results. And that's the beauty of creating this autonomous agent loop. So you define the success criteria, how to test it, and then you give the requirement. And the agent will work autonomously in the loop until it achieves the objective. Okay, looks like everything is finished. Let's look at the results. Okay, where are the outputs? Let's run for reals, for real. So I want to see, okay, did you see that? This used to be 3.9 and it becomes 2.2. And let's see the other one. That one used to be 5 point something and now it becomes 4.1. So it's significantly smaller. And I argued that this photo doesn't need to be such a high resolution, right? Can we further reduce the resolution of the images by 50%? So that would reduce the size even more, like by to only 25% of the original size. Yes, as expected, it's 75% smaller. Let's verify. So this is only 1.4 megabytes. The other one is less than 1 megabytes. Very nice. So I hope this video is helpful to you and inspire you to use coding agent to do some daily tasks like this one. And I'll see you in the next video. And if you like this content, please subscribe my channel and I'll see you in the next video.